Between switch on and switch off is a small interval, usually about 3 degrees Celsius. So our home temperature fluctuates up and down, like our body temperature. And just as we can turn the thermostat up, the body can choose a higher set point suitable for fighting a virus. About this new set point, homeostasis still maintains a narrow fluctuation. Different organisms maintain different set points. Bird temperatures fluctuate about a set point of 42 degrees Celsius. But not all organisms can control their temperatures. As the temperature of the environment rises, the temperature of the frog also rises. A graph comparing the two temperatures looks like this. An organism whose temperature varies with that of the surroundings is called poikilothermic. Birds and mammals respond differently. Organisms which produce a graph like this are called homeothermic. The same graph shape describes many other factors controlled by homeostatic mechanisms. For example, water intake compared to total body water. Or sodium intake compared to sodium in the blood. An overload on the mechanism of homeostasis produces these slopes. The plateau is the range where mechanisms of homeostasis effectively control the internal environment. These mechanisms follow a general pattern. A stress acts on an organism. It is detected by a receptor. The receptor sends a message to a control center where the stress is evaluated. The control center selects one of several possible responses and sends a message to an effector. The effector causes a response to the stress. Usually, there is a final step. The effector sends feedback to the receptor to turn it off or reset it. Receptor, control center, effector, feedback. Consider a simple single-celled organism, Euglena. It converts sunlight to energy in chloroplasts. For Euglena, light is a stress, which stimulates an eye spot that acts as a receptor. The control center for this stimulus is still poorly understood. The nucleus could receive molecular messages from the eye spot and interpret them. Even the chloroplasts are capable of performing this function. But it's quite likely that the control center is the eye spot itself, which is sensitive only to certain wavelengths of light, matching the needs of the chloroplasts. The eye spot may send a nerve-like message through the strands of the flagellum. The effector is the flagellum, which acts like a propeller, pulling the Euglena through the water of a pond towards the life-giving light. It's possible that feedback is a nerve-like pulse from the flagellum, allowing its motion to be coordinated. This general model: receptor, control center, effector, and feedback is a useful tool for the further study of homeostasis.